3, 4.
Hello and welcome to C# Programming on .NET. My name is Brett Robley and I teach at Cal State University Fullerton, and this is ISDS 309. In this video lecture, I'm going to deal with the if statement. This is from Chapter 4, Making Decisions of Joyce Farrell's Microsoft Visual C# 2017 textbook. This program is just something I put together. It's not found in the book, but I put it together to demonstrate some basic if tests, if else, and stacked if else if. Okay, so looking at lines 8 through 13, and especially line 12, I say if 1 is equal to 2, then execute the right line. That's untrue, and so that right line is skipped. In lines 15 through 17, I say if 2 plus 2 equals 4, then execute the right line. And we know that 2 plus 2 does equal 4, and so that right line will execute. Let me go ahead and execute it now so you can see the very first statement that is printed is 2 plus 2 equals 4. Next, in lines 19 through 22, I create a string called name, and I set it equal to Santa Claus. And then in line 21, I test if name equals Santa Claus. Then we're going to execute this right line statement. And sure enough, Santa, all I want for Christmas are my 2 front teeth. I think in the song it may say is. Okay, now moving down to lines 29 through 37. Now we introduce the else construct, where we make a test in the if statement, and if that fails, then we will run the code in the else statement. Okay, so Rudolph is healthy. The first right line is going to execute. The second right line is not going to execute. So I set up a Boolean variable called Rudolph is healthy, and I set it to true. If Rudolph is healthy, meaning if true, then right line, Santa can fly tonight. And sure enough, if we check it, Santa can fly tonight. If Rudolph came down with a cold and he wasn't healthy enough to help Santa, then we would have to record that fact by changing Rudolph is healthy to false. And now when we run the program, oh no, there won't be any toys on Christmas morning. Now in lines 39 through 51, I set up a multi-state variable. I say there are 3 valid states and all others are invalid, meaning all other states are invalid. So I set n as an integer, and I set it equal to -1. And here in the comments you can see that if it's equal to 0, I'm going to interpret that as the HVAC system being off. HVAC meaning heating, ventilation, and air conditioning. If n is set to 1, then I'm going to interpret that as the heater is on. And if it's set to -1, I'll interpret that as the air conditioning is on. So if n equals 1, right line, the heater is on. Else if n equals -1, the air conditioner is on. Else if n equals 0, the HVAC equipment is off. In a final catch-all else, the system is in an invalid state, please call this 800 number for service. So n can store many hundreds of values, thousands of values, but we only care about 0, 1, and -1. And so our catch-all else at the bottom here, handles all of those other values that, if they're set, we know something's wrong with our system and we need some service. Okay, now using compound expressions in if statements, starting at line 57, I'm going to declare three Boolean variables. I'm going to set all three to false. And what are these Boolean variables? Well, this is for my car. So I say the parking brake is on equals false, which means I don't have the parking brake on. Brake is on is false, means I don't have my foot on the brake. Transmission is in park. False means that I'm in something other than park. I could be in reverse, I could be in neutral, I could be in drive, but the point is I'm not in park. And then we have here a logical and. If the parking brake is on is true, and the brake is on is true, and transmission is in park is true, I need all three of those to be true in order for me to say the car will start when you turn the key. If any one of those is not true, then I say the car won't start, set the parking brake, put the car in park, and depress the brake before turning the key. So let's run it and see which of the two statements we get. And sure enough, it says the car won't start. Okay. So now I'm going to change the first one to true. I'm going to say the parking brake is on. So we'll make that true. Okay. And we'll run the code. And the car still won't start. Well, that's because all three of these at line 64 must be true. So let's set the brake is on to true. Now I've got my foot on the brake. And let's run this code again. And as we expected, the car won't start because only 2 out of the 3 is true, but the transmission isn't in park. So I need to get the transmission into park, so I'll put that into park, and I'll simulate that by saying true. Now, all 3 of these are true, and now I expect the car will start when I turn the key. Let's see if we're right. Okay, the car will start when you turn the key. Okay, good. Now, there's a logical or. This is different than and. The logical or says if any one of these is true. The logical and says if all of these are true. Okay, so we have true, 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 and we'll say if the parking brake is on, or the brake is on, or the transmission is park, the car won't move. Check your owner's manual. Otherwise, here we go, better put your seatbelt on. Well, since everything's true, the car won't move. Did I do that right? If the parking brake is on, yeah, the car's not going to move if the parking brake's on. Or if the brake is on, well, I got my foot on the brake, so it shouldn't move. Or if the transmission is in park is true, yeah, it's in park. How's it going to move? So we write the car won't move. Now, if I want to put it into drive, I'll say transmission is in park is false. Will the car move? No, the car won't move. Not if I still have my foot on the brake and the parking brake is on. So I need to release the parking brake. So now the parking brake's off and the car still won't move. So now I need to take my foot off the brake. And at this point, the car is ready to move. Here we go. Better put your seatbelt on. Okay, thanks for watching.